Welcome back. The question is the oxygen molecule has a mass of 5.3 into 10 to the power minus 26 kg and a moment of inertia is 1.94 into 10 to the power minus 46 kg meter square about an axis through its center perpendicular to the lines joining the two atoms. Suppose the mean speed of such a molecule in a gas is 500 meter per second and that its kinetic energy of rotation is 2/3 of its kinetic energy of translation. Find the average angular velocity of the molecule. We are given that the moment of inertia and the velocity of the molecule. Let the mass of oxygen molecule be m. So the mass of each oxygen atom is given by m by 2. Moment of inertia is I equals m by 2 r square plus m by 2 r square. That is giving m r square. So r is root over of I by m, that is 1.94 into 10 to the minus 46 divided by 5.36 into 10 to the minus 26. So which gives us the value of 0.6 into 10 to the minus 10 meter. So we are given that ERT equals 2 by 3 ETRA. So eventually we get the value, putting all these values, we get the value of 6.8 into 10 to the power 12 rad per second.